Hello everyone, this is Stas and welcome to the third part of my Raymarching tutorial series. If you haven't seen the first two parts, I'll put a link in this video, or you can go to this playlist and this GitHub with my Raymarching stuff. The part 1 was about geometry and the Raymarching in general and how the code itself constructed. So if you haven't seen it, it's really important that you know the stuff I covered here. And the part 2 about light and color, it's not so important right now because this one, the third part, would be about geometry again. But this time not about the simple primitives and not about combination of primitives, but about working with space. Because in Raymarching, when we want to create some complex looking geometry, we don't use a lot of individual geometries or instances like in general TouchDesigner polygonal stuff, but instead we do something with space. On my GitHub there is a couple of templates for Raymarching, and if you go into template array, you could see one way of creating the relatively complex looking stuff, where all of this, 15 primitive, 15 spheres is created one by one. And actually it's not a very good idea in Raymarching. On one hand it's good because you could control the position of every of these, let's say, instances. On the other hand, if we start to increase the number of primitives to, for example, 30, okay, I have FPS 60, but I don't know, 80, and it drops, and it's just 80 primitives, not so much. But sometimes on Shadetory or somewhere else you could see very complex geometry with a lot of, or sometimes even infinite number of spheres, and how this could be done. Usually it's done by doing something with the space, because as we discussed in part 1 in Raymarching, we creating geometry by mathematical functions. Let's dive inside some maybe some better maybe here. For example, we're creating a sphere by mathematical saying that sphere exists everywhere by the length. So we took a position, and position minus radius would equal the space around this position where a sphere existed. So everything within this radius is a sphere, and everything outside of this radius is not a sphere. And so we get the positive or negative float number. If it's positive, we outside of a sphere, and if it's negative, we inside a sphere. And this sphere or any other geometry usually took, well, not usually, always took a position as an input. So, and it works as a sphere only when this positional geometry is a normal, ordinary space, three-dimensional space with uniform dimensions, where one unit everywhere is uniform units. So, but what if we messed up with our space? And in this tutorial we will look inside 3 different ways of doing something with space. First part would be about trigonometry, when we use sinuses, cosinuses and other functions to manipulate the space, and here are some results. Another approach is to use modulus to create this infinite amount of geometry or infinite structures. And the third part is about using iterations where to create fractal looking stuff or kaleidoscopic looking stuff. Okay. By the way, this file with green containers would be available on my, it's actually already available on my GitHub, Raymarching in TouchDesigner. Here it is. And if you're one of my Patreon supporters, then you will have these orange containers as well, which it's not something absolutely different. It's the same, but in a more complex, in a more artistic way. Okay, let's start. And one time more, I say that you should watch the part 1 of this tutorial if you don't understand what's going on now, because I hope you understand more or less, you're more or less familiar with this code, with this Raymarching setup, because I wouldn't explain how Raymarching is done. I'll focus on geometry part, and our geometry is here. So let's split the screen, maybe. No, yeah, no, sorry, yeah. Okay, the first idea with trigonometry functions is that we could create some absolutely crazy looking primitive by manipulating our positional. Our position is vector 3p, and if we multiply it with different values, subtract something, add something, do cosinus, sinus function and so on, we could end up with something really interesting looking. And this is not some magical formula. I just did it in, I don't know, in 15 minutes or something like that. I just start typing different stuff and see what's going on until I'm getting something interesting. And right now I could do it, could modify, not so good, could modify it. I will explain these artifacts a bit later. I could add or subtract almost anything. Oops, not good. Sometimes it's looking good, sometimes it's not. You just put some variables until you get something that you like. So and yeah, you could put some variables inside the trigonometrical functions. You could add this trigonometrical, I hope I said it right, functions. and so on and so on. And it could be much longer than this. But let's go back into something that looks better, our starting points. Now, when you have this interestingly looking stuff, and please don't pay attention to this clouds and fog, I'll explain it a bit later. You could use create other geometry like box in the center, and if you add box and the terrain we have, you will get the deformed box deformed by this shape. And you could oops, and you could modify it here as well. You could modify it like I don't know, terrain minus cosine px and so on. Of course, it's a lot about tweaking. You just start typing any numbers, any floats, until you get something that you like. And this is one of those times when I prefer to work inside the GLSL itself, because of course I could put all of these numbers here in my vectors page, but in the beginning I don't know what I want. What do I want? How much of this I want? So it's much simpler to do it inside the notepad. Okay. So a little bit about the fog and this stuff. Usually when you create the infinite space, it's good to not to render everything clear like here, but to add some distance fog or distance, maybe desaturation or something else. And one of the simplest way of doing this is output as a different render select top. And to do render select, you need first in GLSL set number of color buffers as much as you need. So here I said the two buffers. One is my general, and this is the second one. And the second one would be a fog distance, and it's calculated in the very end. Here I calculated in my Raymarcher the distance to the geometry, and I create a variable fog which is 30 divided by distance. It could be 1 divided by distance, and maybe it's even better idea, but then you will need to put math stop here, and find a good value. I know that the 30 is good enough. So here you get distance to the geometry, and what do you want is the farther you go, the more darker this geometry should be. And then you could use this level, this top, for example, level. You could use this as a matte top. For example, here I create simple fog with noise, and I'm using matte top to composite it with my geometry. And another approach is you could use a luma blur and to add a blur, and the blur would be filtered by this same mask. All right. And yeah. Then when you create this, you could manipulate it further and further, and you could get shaped it by some geometry, add more effects, and get something like this. And yeah, if you're one of my Patreon supporters, you will get this example as well, and you could dive in and see what's going on. But in general, it's absolutely the same code with a couple more lines. Well, maybe not couple more, maybe 5 or 10 more lines. Okay. The other very interesting thing with trigonometrical functions, sorry for my English, and sorry for my pronunciation, probably I do a lot of mistakes. Anyway, it's gyroids, or gyroids. What is gyroids? Here we have a very complex gyroid, but let's deconstruct it to make it simpler. I will turn off my modifiers, and here the gyroid in very simple form. Well, the super simple form would be G1 here. Here is a gyroid on the whole space. But usually, if you don't want to create the infinite structure, you will bound it with something. Here I bound it with box with rounded corners. Okay. I wouldn't explain a lot of gyroid for you because there is a very nice tutorial in the YouTube channel called The Art of Code, and I put a link here, and maybe I'll put it in the video as well if I could. So here
40
is all explanation you need about gyroids and how it's constructed and what is it and how it works. But it's made in Shader Toy, and here I have almost the same geometry inside the TouchDesigner. But overall idea is the gyroid is how to explain? Is a specific trigonometrical. Sorry for this word, I can't pronounce this. A function to combine two sinus and cosinus function together to create this. As you could probably see it. This shape, rounded shape, which is very common in the sine and cosine functions. But then you could, on top of this first gyroid, you could add the second one to make it look more interesting. You could add the third one, and the fourth one, and the fifth one. And you will create a very complex geometry. And here the situation is a bit different, because in setups like this I prefer to have these parameters here in my TouchDesigner in my vectors page. So now I could move some parameters and see how it affects, and maybe animate it with sound or Kinect or something else. So probably you see a potential of using this. But yeah, I don't want to spend a lot of time on gyroids because, as I said, there is a very nice tutorial, really recommended, and you get all details if you want to understand how it works. If you want to use it, just download this file and tweak these values, put some music and have fun. What else? Oh yeah, here super easy trick. As I said, we manipulate to manipulate geometry, you could manipulate the space itself. And for example, here in the beginning of my scene setup, I rotate my space on the axis with this speed. If I turn this off, it's not rotated. And another very similar trick is I could move my space, and here it's moved in all three axes, but I could move it in only one axis. So it will now move on X direction, or it could be moved in Y direction, and so on. So this is also a very simple way of deforming a space. And here what is important to understand is that when and where in the code you create a geometry. For example, here the bounds created before I moved a space. But if I first move the space and then create the bounds, the effect would be different. Actually, we don't see anything. I don't want to fix it now. Probably it would be easier to show it like this. Here I'm rotating both bounds and gyroid, but if I move rotation here, only my gyroid is moving. It's moving very fast, but if you could notice, the boundary of this geometry stays the same, while here it's rotating and the bounds moves. Okay, what else? And here is a trick to deal with artifacts, because usually in Raymarching we return our final distance function, but if I return it like this, I'll get a lot of artifacts, and no matter how much I would minimize my minimum distance, I still get these artifacts. And why is that? That's because because the Raymarching works very well if we have a uniform space. When we don't do any sinus, cosinus and rotation and everything else with our space, because all of our formulas works well when space is uniform. But you could imagine if a space is very warped and non-uniform, and yeah, if it's warped, then these formulas stop working. It doesn't work as expected. And what could we do? Here is a two-dimensional representation of Raymarching. For example, here is our viewpoints, and we calculate in our Raymarching setup, they calculate the safe distance to move, and then another safe distance, and another, until we reach some border. But and it works really well all these radiuses of marching radiuses works really well when our space is uniform. But imagine if so it says, for example, from P0 to P1 is I don't know, 2 units, and it tries to go these 2 units, but maybe our space is warped with sinuses and cosinuses, and for example here, because of this, we end up not on this border but inside the space or somewhere else. So our steps doesn't work as good as it works in uniform space. I hope my explanation is somewhat clear. So what could we do? Instead of this full safe step in Raymarching, we could multiply our step into some number to get our step not as big as it could be, because now is the radius of a step is a radius till the closest point. So here is our radius, and for second point is we still going until we reach something else, and then until we reach something else, and so on. But what if we move, for example, 2/3 of this space? So what if we move here? And if we don't reach anything, we could move a little bit more, and a little bit more, and a little bit more, and so on and so on. And if we reduce our step, then even if we have some warped space, there is the chances that we don't overstep and don't go inside geometry, it decreases. Because all these artifacts is going on because we overstep our geometry, and our Raymarcher thinks that we not inside our geometry but outside, so it's colorize it as it colorize outside step, so dark in this setup. So we could multiply it by something, and it works. But it slows down our whole setup. So in general, this number should be as close to 1 as possible. But I experiment with this geometry, and for example 75, I still get some artifacts. 65, still sometimes some artifacts. 60, okay, 60 works, but 55s works better. Oops, 55s. So if you get artifacts, try to use this trick, but don't do this, because if you do this, you don't get any artifacts. But well, okay, right now I still have 60 FPS, but if geometry would be more complex, maybe it will drop. And sometimes with smaller numbers you get the artifacts start increasing once again. And one more trick I used here is usually here in this minimum distance variable is just a float, one number. But here I use 2 numbers, because I discovered that sometimes it's interesting to use in normals, in normals estimator, not the same minimal distance as in my general Raymarching, but a different value. For example, if here is my value for my normals, and if I do it like this, it's really interesting look, because normally it should be the same in normal setup, and it's good, nice, crisp geometry. But sometimes it's interesting to calculate normal smoothly. Well, maybe not so much, but yeah. So experiment with this as well with your Raymarcher, and it's done very simple. Here instead of float I put vector 2, and in my normals I use y value, and in my Raymarcher I use x first value. Okay, and the fog is calculated, yeah, it's calculated the same way, 1 divided, and here I'm not using the fog, here I'm not using it for fog, only for a blurring. Okay, Gyroids is done. And yeah, as a bonus example for my Patreons, it's the same gyroid, but I combine different gyroids in another way. So I put gyroid inside a gyroid and do different colors for them. Okay. So let's go into the second topic. The second topic is repetition. And again, let's start with super easy setup, because now it's looking not so easy, not so clean. Let's I put it here as 1. I turn this off, and I turn this off and this off. Okay. The modulus. The way of creating a repetition is a modulus function. And here we modulus. Here in the book of shaders, this is example where it is. Okay, here it is. Modulus works, it's almost the same as a fract, but it returns the modulo of this value, because the fract returns as if it's equals 1, so it's the fract returns the fractional part of any number, but the modulo returns like a fraction of, for example, 0.5, or a fraction of 1.5, and so on. So you could imagine that before, like so let's say here is our two-dimensional space, and our P is, our space is uniform, like here. But if we add models, it starts, it's repeating. It's making this a repeating pattern. And we could just do the same with our three-dimensional space. We could add modulus on one of our axes, for example on x, on 2 axes, or in all 3 together. So in the end we have, and we did it with our space. Here I create a new variable called the new position, and it equals with the old position, and I start manipulating and deforming, warping this value. And then I create the sphere in this warped space. So if I create a sphere in normal space, it would be just a sphere, but in this deformed space, it endless amount of spheres. And very often it uses just like this, just a uniform repetition. And you could fly inside, or instead of sphere you could create some boxes or some very complex geometry and work with that. But it's interesting to make it not so uniform, to somehow randomize this uniformity. So here I use a built-in TouchDesigner function to desimplex noise, and I create new function called random. It took vector2 as a variable, and I return the desimplex noise, return the value between -1 and 1, and then I rearrange it to return the value between 0 and 1. So if I feed to this random value the vector2, I'll get as a result here, I'll get the number between 0 and 1. Oh, sorry, I want to show you a little bit more. This repetition parameters, I put it here, and this works. And how spaced, what is the space between our repetition values. And this, the fourth parameter is 1 divide on this first parameter. And we could use it to create, let's say, space cells. So it's so as I said, the modulus, you could think about modulus as about fraction, and so here we want to return not the fraction but the floor. But because the modulus is not a fraction of 1 but a fraction of something different, we need to multiply it by 1 divided by this value of mod. So what does it do? What does this trick do? Here I create these space cells. I feed it as to have my noise, add the U time only to y-axis, so only to the vertical axis. If I put it x instead, well, I need to tweak it a little bit differently, so okay, y. And this repetition y is just the speed. And why did I use this space cells? Because if I use just the p, so our normal position, it would create this instead, because our spheres would be, we could get rid of this artifact with the same trick, but still we have here our y-axis would be deformed on the whole space, so every of our sphere would be deformed as well. But with these space cells, inside the space cell, the value wouldn't be deformed because it's a floor function. So the random here would be the same. And yeah. And in the end, we have this effect. Okay. And the movement right and left, it's because of a camera. I can turn it off. It's just falling down. And the same trick to reduce artifacts. Okay. How could we do non-uniform space in other way? Let me show the space number 2. Boom, 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 boom. Okay, the another idea, we could scale our spheres, and we would scale, we would use the same random functions in the space cells. So we will, here we get the value between 1 and 0, and we could use the step function. The step function is here. Here is a step. The step function return 0 until we reach this value, and return 1 if this variable would be more than this. So if st.x is more than 0.4, it return 1, and otherwise it return 0. And here I use the same. If my random is below this parameter 0.3, the scale of the sphere in this space would be 0, and if it's more than 0.3, it would be 1, so it would be a normal scale. So, and this allows me to, if I have a less than 0, I have the all spheres, and if it's more than 0, I start to the sphere disappears. It's not actually disappeared, it's just become the sphere with a radius with a scale 0. And oops, if my value here is 1, all spheres disappear. Okay. So, and in the end, we could combine our two spaces, and notice that here I create another position. So here was my original position value, original space. Here for the first effect I create the new space number 1, for the second I create the new space number 2, because we have a different deformation of the spaces. And now I could union these two values and get my spheres falling down, and also smoothly combined together. Okay, I hope that's also understandable. And let's see how the fog. Okay, here the fog distance here is created a bit differently because I wanted to show you a little bit different approach. Here the fog created as a smooth step between these two values, fog distance. So you could manipulate fog in real time. And if you like this approach more, you could use the same approach for the other components as well. It's not something that you should use here in endless grid. You could use the same approach in our gyroids, in our trigonometry function, and the same you could use the old trick from here. So that it's interchangeable tricks. And you could do different tricks with this repetition. For example, for Patreon supporters, they would see also this, how it is done. And this is actually a trick from the Luna sorcery. There is a very interesting, on a shade editor there is a lot of nice and very skillful artists, and some of them do a live coding section on a Twitch. And the Luna sorcery did a very interesting stuff with geometry, with very good explanations. It's, I would say it's advanced material, but I really recommend to see it. And this trick to warp space into this kind of Möbius-like toroids, it's just a... Let me show you the original. Originally we just shape it into this Möbius-like torus, and yeah, and we used just a normal mod to create these boxes. And this is her trick. I learned from one of this, probably from this one, from episode 20, or maybe from episode 15. I don't remember now. So I really recommend, when you become more or less fluid with Raymarching and with working with geometry, I really recommend to start seeing these live coding sessions. And you will learn a lot of interesting tricks. And I'll put a link somewhere in the description or somewhere else. Okay. So, the endless repetition and endless grid. It's almost the same stuff. But instead of the spheres, I have a grid here. And the grid, let me output my grid. Let me turn off the rotations and the twisting to show you how it's constructed. So the grid is actually the combination of endless rods, endless bars. So we create endless bars in one direction, then we add to them in second axis, and we add them in third axis. And the parameter, your repetition parameter x, gives us the same as in our previous example, the spaces, the how much separated they are, our bars. Okay, but then we could rotate. Okay, let me show the twist first. We could twist our grid on on z-axis and on x-axis. Here it's twisted on z only, then I twist it on x, and again I twist my space. Here's I code repetition. P is space, P is because of position. maybe, yeah, I used the word space in this tutorial, so probably it would be better to use the variable not p but space, but okay, I hope you all understand. So here I twisted it, and I could also rotate my space. Actually, I did rotation first and then twisting. If I do it in different way, it looks almost the same, but a little bit different. And I create the grid in this rep space. Octahedron, on the other way, is created on our P, in our original space, because I don't want any repetition for my octahedron. So my octahedron is here. It's only one, because if I create the octahedron in the same repetition space, well, it's too large. Yeah, here I could have the endless amount of octahedrons in my warped space. But now I want only one octahedron in the center. And then I want to combine it together. And probably you're asking, why is this not a float now but vector 2, and why we have such strange stuff? And if you're asking it, then you need to watch the Raymarching part 2, lights and colors, because in here, somewhere in this tutorial,
It's called.
And it helpful.
somewhere, oh here, somewhere around 30 minutes, I explained how to colorize geometry, how to colorize differently different geometries. And here I'm using almost the same trick. It's a little bit different from what I explained here, not because it's better, but because I wanted to show you a little bit different approach. But overall, the idea is the same. For each of our geometry, for our grid and for our octo, we set let's call it ID. For our grid, let's say we have ID 0, and for octahedron, ID number 1. And then in the line 2 to 3, on the line 2 to 3, I said to mix the colors by this distance, y would return the value between 0 and 1. 0 for my grid, 1 for my octo, and something in between in this smooth union stuff. And here this function will mix the colors as well between this and this. Okay, the fox is the same as it was before, so nothing new. Yeah, probably that's it about the grid. Yeah, and because of vector 2, I'm using a little bit different function. Here is our ordinary smooth union function, but if you want to feed it vector 2, it's just a little bit changed, not so much. Okay. And the bonus patron example for this one would be this. So here, what's going on? A little bit more coloring, a little bit more warping geometry for the grid, and instead of octahedron, it's a torus with some sinus deformation. The deformation of this toroid it's constructed in a similar way as I showed here with a box in the very beginning, if you still remember that. Sorry, I think this tutorial would be very long again. It's about 1 hour already, but we need to cover more things. So let's move on to the KIFS. It's a kaleidoscopic iterated function system, fractal system. Yeah, kaleidoscopic iteration for fractal system. Yeah, fractal system. Am I sure? KIFS. Iterated function system, not fractals. Anyway, what's going on here? Let me first turn off this. Again, I'll just show you from the beginning. We could create the for loop and somehow modify our space in this for loop. And first modifier would be given the absolute position of a space. Absolute position works like a mirror in a way. Where is this absolute position? Absolute position is absolute position. So negative becomes positive and positive stays positive. So in a way it works like a mirror in the center. And this is a distance to our mirror in a way. So I created the box here, the long boxes on the bigger y-axis. And with this position, I just mirrored it. And again, I could mirror it in only one axis, or in 2, or in 3, but in this here you couldn't see the third one because it's very long and this distance is not so long. If I put it here, you could see it's mirrored in all 3. So it's a mirror, but that works in 3 axes. Very weirdly looking mirror. I couldn't imagine how should it be constructed. Anyway, so I mirrored the geometry. 0.2 it was, I suppose. 25. Yeah, 25 is good. And here the 4th position of our KIFS variable is it should be integer, but here I'm using the special string. It's not necessary, but I like to do it. Let's say this, even if here I have a float, it's still, until I reach 2, it's still integer. And here is a number of iteration. The more I iterate, the more, let's say, mirrors we create. But let's first start with one mirror. So we set our mirror, our absolute value, and then we could rotate our space. I rotate in x, y, z direction with corresponding values. Here I set the same value, same angle for every axis. And my geometry start rotating. And don't pay attention to the coloring. The coloring appears because of normals, and I explained it a little bit later. So it's rotating, and if here it's rotating in the same angle everywhere, but if I here now the angle of rotation is different for every axis, and I could add some more modifications, add some more modifications, add something else, add something else, and in the end you could create something between kaleidoscopic or fractal looking stuff. Especially here we have only one iteration, but if I say have it 5, okay, it's too big now. I need to move my camera away. And again, you need to tweak the values. I suppose it's because of this line here, or because of these lines, or because of this line. Yeah, because in this line here, and yeah, this one is, yeah, this one makes it very big because multiplication by 2. This line here, it moves our space on some value, and on every iteration our value become more and more, and that's why if you have a lot of iteration, our geometry disappear because it moves very far away. But it doesn't mean that you shouldn't use this. It's just you need to tweak your values, you need to tweak everything to get what you're looking for. Okay, so here I created a box, but I could do the same with, for example, a torus. And again, I need to tweak values because now it disappears sometimes. Maybe I move it here. Okay, anyway, I hope you got the idea. And I could use the grid, the same grid as was before. So if you like this kaleidoscopic fractalic look, you should dive into this part and tweak these parameters. And it's called kaleidoscopic iterative functions because it's kaleidoscopic, mirrors, and iterative iterations. And the normals, here for the second buffer I return normals. Normals are calculated here in the function estimate normals, and I just return it, and here my normals, and I'm do some HSV adjust, some composite, and use normals for coloring. It's a super cheap and funny looking trick to colorize geometry. But of course you could colorize it with normal stuff. And of course you could create more than one geometry, because now I have only one geometry like grid, but of course I could add more. And as a bonus example, here is actually it's about the same. If I return a box here, you could imagine this box is this one, but I move them apart with something like this variable but more tweaked. And I create the decahedron in the center and use a smooth minimal and also colorizing. Okay. You could also use the GIFs for creating fractals. And here I want to, here is the Manger sponge, very famous fractal. And when you creating some famous stuff like Manger sponge or Julia set or Apollonial gasket or something else very well known, then probably you could create it by yourself. Let me just return, because it's looking a little bit weird to you, maybe, if you probably you're more familiar with this one. Return fractal P. Here is the Manger sponge, and the colorization happens because I moved because my lights is moving up and down and up and down. So sometimes if you want to create something famous, something very well known, like famous fractals, you could just define the code on Shader Toy. For example, here on Shader Toy I found a nice looking Manger sponge. I copied the geometry. I copied this geometry, this one. As you can see, it's almost the same. I'm using some parameters from TouchDesigner to do it more interactive, but overall the function is the same. And it's very good for learning, because well, maybe for the Manger sponge it's not so complicated. It's constructed not very simple, but relatively simple. I could return, for example, it's constructed by creating this cube with removed cross. Removed cross, this geometry, and that it uses the iterative function, they're almost the same as we have before, with iterations, 4 iterations, to return, to multiplicate it with a decreasing scale. Every time we decrease the scale, move position a little bit and do something more. So probably if you're good at mathematics, if you're good in visualizing stuff, you could come up with this formula by yourself. But if you couldn't, my advice to you is to go on Shader Toy, look for fractals you like. For example, there is a lot of different Manger sponges and Manger sponge geometries. So you could copy this geometry part of code, give it a credit to the author, and learn by yourself how it's constructed. In this one, I really like this trick with a plane. So here is our old boring Manger sponge, but if instead we return, if we cut it with a plane, you have this nicely looking geometry. And you could feed the parameters from the TouchDesigner, again to manipulate it with some, I don't know, mouse, lip motion, music, and whatever you have. yeah, so I wanted to, what else did I want to tell you about this? Yeah, probably that's it with Manger Sponge. Yeah, probably that's it. And yeah, if with Manger Sponge you could possibly come up with it by yourself, if you go into Julia or something like this, it could be really hard to understand it. It would be really hard to do it by yourself. So Shadito is a good resource for finding. Here's the Julia Fractals. Actually, it's sound. Anyway, so this is a bonus example for my Patreon supporters, and I would really enjoy and would be appreciate you. Sorry. I'm speaking for more than 1 hour in my bad English, and I start mumbling, and yeah, let me drink. You need to drink from time to time. Okay, focus, let's focus, because we have the only one container left, and it's called mixing everything. Ba-bam. It doesn't look very exciting because I'm not very good in this, in creating such stylistic. It's very popular stylistic among Damascene artists, and I could again recommend you to see this guy, Evil. He also have a Twitch TV Evil, and he really good at creating this fractal, iterative looking, abstract, Damascene looking geometry, which is looking nice and abstract and moving and kaleidoscopic. But here how it's can be created. How it's created. First, let me turn off this for a moment. First, I created a geometry. So here in this function, I'll just return this function. Here is my geometry. It's again vector 2 with a coloring. It's again a little bit different approach to the colorization. To show you another one method. It's about the same method, but without the smoothing between colors. So we get an object color here, one of this, and use it as an ambient light for our geometry. And this is overall the brightness of an ambient. Or saturation of ambient. Okay, but again, this tutorial is not about coloring, it's about the geometry, so let's see what's going on here. Here I have box with so for every part of geometry I created my own space. And I have two spaces, the P space and a clean P space, and I explain it later, but right now it's the same because here is a clean P equals P, so don't pay attention to the P and clean P right now. So here we have our boxes. We rotate it, we do our modulus function and the ABS. Let's deconstruct it. Here we have our box with absolute values, the more boxes, and they goes down on the 0 axis because for the 0 we have multiplication with dynamic variable u time. And now let's rotate in one direction, and if we rotate with the axis and the degrees would depend on the same axis, it would work as a twist. So if I turn off this rotation, it would be just a twisting. But here is rotating boxes. Okay. Another tricks for the octahedron. Octahedron, where is my octahedron? Here is my octahedron. So for octahedron, I do only rotation. Super simple. And for the torus, it moves up and down, and yeah, and rotation. That's it. And when we combine it all together with coloring, we have this one. So this is our initial geometry. We've already morphed space, or three differently morphed space, as we discussed before, how to morph, how to do modulus, how to do rotations. And now let's use this geometry. Let's assume that this is a single geometry. And now let's do iterations. So here is our iterative functions. And our iteration functions is the same as in GIFs. And here for repetition we have parameters. If I set it to 1, we have, if I set it to 0, we have no iterations. And now I could iterate. And some parameters. The only thing which is different from what we discussed before, that here I'm creating a new variable called cleanP. So why is this? In iteration function, I'm always modifying only P space, but I do nothing with a cleanP. So when I feed the main geometry function with this modified P and unmodified clean P, I could use this iterative modified P or clean P. For example, here for my boxes, I'm use non-iterative clean P. So for my boxes, I don't use iterations. If I use the normal P, then my boxes would iterate as well, and it would be and every line of this code and every iteration would be performed for my boxes as well. But it's really messy, I don't want it, so here is my clean P. And for example, if I don't want it for my torus, I could do for my torus as well. And now I have iteration function only for my octahedrons. So, and this way you could choose when you want to do the kaleidoscopic effect for some geometry and don't do the same effect for the other of geometry. But again, as I said, I'm not a super big fan of such kind of kaleidoscopic abstract stuff, so probably it doesn't look very exciting, and I hope you could do it much better, and I could recommend you to watch this guide too, because it's much more cleaner. But to do such a super clean one, you need to tweak these variables a lot. And he has the twitch as well, and usually
we'll start in a few minutes.
It spends like
what's happening. We're
several hours to create
from scratch
such kind of stuff. So that's why I do this a super simple setup, just to show you the possibilities. And this is it. So we're done. Whew. I don't know how long it is. I couldn't see it now, but I hope you're not super tired, or at least you're less tired than me. And if you like this tutorial, please leave a comment, subscribe to my channel if you want some extra examples and different stuff as well. You could support me on Patreon to download this green discussed geometry, not discussed but discussed by us geometry. Go to GitHub, enjoy, make art, keep safe, do fractals, warp space. See you, bye bye.